think there were some concern regarding the density of these talks. Okay, don't worry about that. What you need right now is to take and catch the general idea. Okay, you will have after the lecture, you will have posted in the platform, the Moodle, you will have two documents. One is a description, a description of what you need to know in general. Okay, that's a description of each part. So it is in that moment in which you need to understand everything. Understand. Okay. There is also the presentation, the same presentation that I have brought here. It is going to be in the platform. You will have then the forum and chat. And finally, you will have the auto-evaluation. So the auto-evaluation is the last point. But it's a way for you to detect how much do you need to know. Do you need to respond in a case, in a sudden case, okay? If somebody is asking something to you about that, you need to respond in this way, okay? So right now, what I want is to give you this general ideas to understand, to make you to understand the books, the description that I have plotted on the platform. Okay? So, as a lectures today, we are having the description of the whole anatomy. Okay? From the spinal cord to the highest point of the structural organization of the nervous system. That is the neocortex. Okay? It's the more complex area in the brain. But right now, we need to descend to the pedestrian, okay? That is walking, standing, or sensory, okay? So this is the spinal cord, okay? This is the second part. Okay, the spinal cord is a tube. It's a tube along the vertebral canal. It has two enlargements. One enlargement, too fast. Okay, one enlargement at this level. Okay, that is enlargement corresponding to the upper limb, and another enlargement corresponding to the lower limb. Okay, this means that upper limb and lower limb needs to have a greater control, okay? A greater sensory control and also a greater motor control, okay? For all the spinal cord, we are having pairs, one on each side, of spinal nerves. So what means is that each segment of the spinal cord is receiving sensory information for a band of skin tissue, and also is controlling a band of muscular tissue. Okay? In some species, in some organs, some parts, like in the upper limb and the lower limb, this structure in these kinds of bands are a little bit disfigured. It's just a little bit measured. But it still remains that there are some parts that are controlled by one segment and other parts that are controlled by other segments. Okay? So the spinal cord is inside this tube. Yeah, well, I'm going to catch it behind.
Okay, I can do a separate one.
It's okay. I think it's okay.
All right.
And
also, I told Professor Proper about your concern from yesterday lecture. Okay, and we will put all the details that you need on the platform, so don't worry about anything. Okay? You have 55 minutes now.
55
minutes. Okay, goodbye.
Okay. Okay, so we are having pairs of neurons, and also we are having pairs of ganglions. So ganglion are neurons that are derived for the neural crest. Do you remember the neural crest? Okay, so are pairs of neural crest neurons that appears in the joint between vertebrae, in the intervertebral foramina. Okay, and it's receiving information from the skin and sending information to the spinal cord. Okay, so this is a tube inside another tube, and inside a canal, but there are several spaces, okay, that are depicted here. Okay, one space is between the spinal cord and an envelope, and the other space between the envelope and the vertebrae. So these spaces are depicted here. So this is the vertebral body. This is the spinal cord, and there are several envelopes. Okay, we are having up to 3 envelopes, 3 layers. One layer is the pia mater. Pia mater. The pia mater is ensheathing the spinal cord. Okay? This is the inner envelope. It is continuous all along the nervous system. And we are having also another envelope that is outside. This is thin, but this is thick. This is thick. Thin and thick. Thick is because it's conjunctive tissue, very hard and dense conjunctive tissue. Okay? Isolating completely and protecting completely the nervous system. Between the two, this is called dura mater. Between these 2 layers, we are having a dispersed conjunctive tissue. Very loose, can be separated usually, and this loose conjunctive tissue is called arachnoides. Spider-like. Arachnoides. So all this tissue, all the arachnoides, contains liquid that is the same composition of the liquid of the cephalorachidtic liquid. So it's a normal cerebrospinal fluid. Cerebrospinal fluid. All this part and inside the canal. And this space is called subarachnoidal space. Okay? Still we are having another component that appears between the dura mater and the bone. Okay? The dura mater and the bone. This space is called epidural space. It contains fat. Okay? And this is the space that is being used for anesthesia in the lower part of the body, because as the spinal cord increases, the anterior, there is the bone. The bone grows more than the cord, so it apparently increases in space. It apparently is pulled up, but this is not real. In fact, each segment still is connected with its own canal. But there is a space here between the dura mater and the bone. And this space that contains fat is in the middle of all the nerves that takes off the vertebral canal. So if you put here a compound, an anesthetic, this anesthetic will take off the conduction. That's the reason of the anesthesia. Epidural anesthesia for delivery, partum, and also for several surgeries over the lower limb. Okay, so like knee surgery and so on. Okay, so let's go inside. What is most important for us. Okay, so this is a representation, a general representation of we are having in the spinal cord. Basically, we are having two components. It's the gray matter and the white matter. Gray matter is surrounding the ependyma and have a butterfly-like shape. Butterfly. Okay? This is the gray matter. And we are having white matter. Okay? Gray matter is composed of neurons, grouped in a particular way. And white matter is composed of cords. Cords of actions. Bundles of actions. Okay? Regarding the gray matter, we are having three components. The dorsal horn. Dorsal horn is mainly for sensory systems. Ventral horn. Ventral horn is for motor systems. And the intermediolateral area. The intermediolateral area. The intermediolateral area is for sympathetic innervation, for sympathetic control. These are the preganglionar neurons. Okay? So there is, I have plotted here the two main divisions. We can consider the cytoarchitectonics or the general anatomical division. So the general anatomical division makes several subdivisions of the dorsal horn, ventral horn, and the cytoarchitectonically it has been divided into consecutive longitudinal layers from the dorsal to the ventral. Okay? This is the so-called lamination of Rexet. Okay? It is very popular in the scientific papers. Okay, but nevertheless, what we are interested, we are not going to be in detail. It's in general, we are having dorsal, intermediate, and lateral, and ventral. Okay? Regarding the fiber tracts, we are having three kinds of tracts. We are having ascending tracts, descending tracts, and intersegmentary tracts. Okay? So in this image, ascending tracts are plotted on the right, and descending are plotted on the left. Okay? Structurally, we can define three parts. One part will be between the dorsal sulcus up to the dorsal horn. This is called the dorsal column. Dorsal column or dorsal horn. We are having.
It's the part of the horn and the white matter.
It's the white matter. The white matter can be divided in two ways. Regarding the track, where it's going to, or regarding the position. Okay? Regarding the track, we are having ascending, descending, and intersegmentary. Regarding the position, we are having a dorsal horn, a lateral horn, which appears between the dorsal and ventral horn. That is the lateral cord, lateral cord, and the ventral cord. Ventral cord is ventral or is surrounding to the ventral horn. Okay? There is not a clear-cut landmark between the lateral cord and the lateral cord and the ventral cord, but this is very fairly is very well defined, the dorsal cord. Okay? And the fasciculus proprius is the intersegmentary. It's the intersegmentary tract surrounds all the gray matter. It's between the gray matter and the white matter. And it is composed of actions relating one segment to other segment. Okay? Imagine we walk just moving the hands and the legs. The upper and lower limbs. Okay? So this means a regulation of both parts at the same time. And you don't care about mind to control this process. Okay? This process can be done automatically. Okay. So these are the main divisions. So let's go through how it is organized in several ways. So sensory systems are mainly dedicated to the dorsal horn. Okay, to the dorsal horn. But we're having two ways for conduct sensory systems. Okay? We will go again when we speak about somatosensory. But we can separate a fine tact, okay, the tact that is taken whenever I'm smoothly touching something, or when I can detect in the Braille lecture, reading, I have very close and narrow fields in order to separate points that are very closer. So we need a very fine tact, a very fine separation. Okay, this track type of sensation comes over. Comes on the dorsal column, and this is a sensation that runs over the spinal cord without synapsing. Okay, it will arrive to the brainstem, lower parts of the brainstem, without synapsing, and on the ipsilateral side. Okay.
Doctor, can you repeat it again, please?
Yeah. What I mean is we're having different kinds of tactile sensation. One is the fine tactile sensation. The tactile sensation is that one here. Okay, it enters the spinal cord, but it does not cross. It remains on the same side, and then ascend, and will arrive up to the lower parts of the brainstem without synapsing. Okay? This is the fine. And the other one is the coarse. Okay? What is called protopathic sensation. Something is touching to me, but I don't know what is. Okay, maybe the skirt, the sleeves, and so on. But at this moment I can define accurately what it is, this general touch. Okay? And this sensation comes together with nociceptive sensation, pain. Painful mechanism, okay, runs together with some protopathic sensation. So this protopathic sensation enters into the spinal cord, makes synapse over the dorsal horn, and from the dorsal horn, part of this sensation, most of this sensation, grows contralaterally. Okay? And makes these two tracts. These two tracts will be here. Okay? So the natural way is to run, contact dorsal horn, crossing to the contralateral, and then originates the spinothalamic tracts. Okay? There are a couple of them, not only spinothalamic. Spinothalamic is when this tactile will become cognition. So you will aware of what is that sensation. But you are having several other tracts over there that are spino-reticular, spinotectal, and so on. We analyze several aspects. But at the moment we are having one sensation, epicritic, fine tactile, that does not relate in the spinal cord, and another sensation that is painful, nociceptive, and protopathic, and with course contralaterally, and run contralaterally. Okay? So several diseases or several traumas that broke half of the spinal cord. Whenever you're having a lesion in half of the spinal cord because you're having an accident and it broke part of the vertebra, and then it cuts half of the spinal cord, and the other part remains in its own way. So you're blocking here, and you are blocking this part and that part. Okay? And you lose to be an arlequin. Okay? So you lose sensation, epicritic sensation from one part, and nociceptive sensation for the opposite part. Because it's crossing.
He can move his hand, but
no, well, it cannot move. Well, it cannot move the contralateral. It cannot move the contralateral, the ipsilateral part. It can move ipsilateral. It loses the sensation of the epicritic sensation of the ipsilateral and the nociceptive sensation of the contralateral. So it's something. It's arlequin. But this is a syndrome. It's a syndrome of the cord section. It have a name. I can't remember. Name of the one that... Okay, so that's sensation. Sympathetic system. Okay, so sympathetic system is represented in the area surrounding the aqueduct between the dorsal and ventral horns. Okay. And this area contains neurons over here, which lives together with motor fibers and then enter in all the ganglia derived from the spinal crest, from the neural crest. Okay? And from there it will control mainly the vasculature. Okay? Vasoconstriction or vasodilation of the, in this case, muscular vessels, and in this case, visceral vessels. Okay? This is sympathetic system. Okay? That area. And what we are having right now is descending corticospinal tracts. Okay? We are having one crossed corticospinal tract and one uncrossed corticospinal tract. So these tracts comes from the motor cortex. Okay, motor cortex, and from motor cortex it descends over the brainstem, and most of the fibers cross contralaterally. So this is called the pyramidal decussation. It runs from the cortex to the brainstem, and at the level of the brainstem, most of the fibers cross contralaterally, and this is called the pyramidal decussation. And then we will have the contralateral cortico-spinal tract. Okay, from the cortico-spinal tract, we will have fibers that at the corresponding level will leave the tract and will contact with the ventral horn. Okay? Most of these fibers does not contact directly to the motor neuron. They contact with the interneuron. Okay? So we will have here a contact with interneuron, then interneuron to neuron, to motor neuron. Okay? So the regular tract is corticospinal tract. From the cortex, I am conceiving a movement, okay, and figure now a movement, and then transmit the order contralaterally, and then to interneurons, and from interneurons to motor neurons. Okay, and finally, the places, the tracks, the